Thank you for joining the class with me. So today I'm going to start with the fraction, right? Okay, so let's look at the screen. Are you able to see the screen, everybody?
Yes.
Yes? All right. Okay, so how many of you have done fraction this year? And as COVID time, have your teachers done fraction at school this year so far?
Yes.
Yes? All right. Okay, so let's look at the screen. Oh, because I think all of you are unmute, right? So I'm going to ask you questions. If you want to respond, just unmute yourself so I know, right? Okay, so I'm going to start with a few vocabularies from fraction, right? So equal parts, okay? And numerator and denominator. Can somebody tell me what is a numerator? What is a denominator in fraction? Yes, Glenna?
A denominator is a number that is bigger than the numerator, and the numerator is smaller than the denominator.
All right, so can someone tell me, is that exactly true? The denominator is always bigger than the numerator? Can someone answer the question?
It's not true.
Okay, so Glenna will explain that later on, okay? So I just want to know how much do you understand about the relationship, all right? Okay, so in a fraction, there's a number at the top, there's a number at the bottom, right? Okay, so where do you write the denominator? Where do you write the numerator? Which one is at the top? Which one is at the bottom? When you're writing a fraction. Okay, only two people, responding. So I'll be asking questions, right, when I'm having a class, right? Okay, so I'll encourage your participation and respond to my questions, right? You can unmute yourself, right? So you might have to pay attention, unmute yourself, right, from time to time to respond to my questions, all right? Okay, so I asked the question again. So when you're writing a fraction, right, there are two numbers. One is the numerator, one is denominator, right? And you have a bar in the middle, right? So one number should be written at the top. One number should be written at the bottom. Numerator should be at the top, or denominator should be written at the top.
Numerator.
Numerator, yes, very good. Okay, so next we're going to introduce this later on. Okay, so what is an equivalent fraction? Anybody would like to respond to this question? What is an equivalent fraction?
I think it's the numerator and the denominator has the same number on it.
Has the same number on it? Okay, we'll find out, all right? Okay, just be brave, even like if you're not sure exactly, right? So that way I know how to emphasize, how to explain more a little bit, right? Okay, so what about common multiple? What does common multiple mean? You're not sure? Okay, so there's something I think probably your teacher hasn't taught you.
It's like the number that's like a number that the number will multiply something and it equals to the denominator and numerator, or two numbers.
All right, it's okay, right? Okay, so we would explain later again. So what is the lowest term? What is the simplest form? Have you heard of it?
Oh, also, I think it's like I think like if it's 4 out of like 2 out of 4 equals to 1 out of 2.
Very good, right? Okay, you take out all the factors between those two, right? Okay, all right, so I kind of know where are you at now, right? Okay, so I think you will learn something new today. So I hope I can help you understand, right? Okay, next page. I'm going to start with some very basics, all right? Okay, so now let's look at the screen, right? Fractions actually means equal parts, right? So equal means, no matter how many pieces you cut the shape into, right? Each piece should be exactly the same, right? They have to be, with the same sizes, right? Now you look at the circle, you look at the square, you look at this parallelogram, right? You cut them into, now these are like exactly in halves, right? But you can cut them into more, pieces, right? Can be into fourth, can be into, eighth, or it could be into 12th, right? So these are equal, all right? So again, fraction means equal parts. So now let's look at this, right? Now, is this equal? Are they equal? Are they in equal parts?
No.
No, right? It's so obvious, right? So we cannot really write a fraction out of this, okay? All right, so next, so now are these equal parts?
Yeah.
Yes, right? Okay, so now for the one on the left, okay, so how do you write the fraction for the one on the left?
1 out of 2.
1 out of 2, yeah, the shaded part is 1 out of 2. And the one on the right?
1 out of 3.
1 out of 3, yes, very good, right? So now, okay, why you said the one on the left, the denominator should be 2? How do you decide the denominator is 2?
Because they have separate 2 parts.
Right, because there are 2 parts, right? 2 equal parts. So the same as the way on the right, right? So the one has 3 equal parts, right? That tells you, right? What do you have to put, right? For the denominator, right? And the one means the shaded parts, right? Okay, so now I was asking you guys the question earlier, right? So denominator should be written at the bottom, right? The numerator should be written at the top. So how many pieces together, right? That's the numerator. How many shaded parts should be the denominator, and the shaded part would be the numerator. Anybody has any question about this?
No.
No, okay, so this is easy, right? Okay, so now look at this, right? What's the fraction?
2
out of 4.
2 out of 4, very good. I'm sorry, because I think there are more students, right? So I can't really see. So, okay, so if you want to respond, it's okay, right? If there are too many people.
2 out of 4 equals 1 out of 2.
All right, so we'll do that later. Okay, the denominator would be?
The denominator.
What is the denominator? The number?
It will be 4 or 2, I mean.
No, denominator.
2 out of 1, 1 out of 2.
Okay, no, wait a minute. What's the denominator?
4.
4, yes. Okay, that's what I want you to say, right? So the denominator means what? How do we know the denominator is 4?
Because there are 4 equal parts.
Right, okay, again, remember this, right? 4 equal parts, right? Okay, so this is the denominator, right? Okay, the numerator is?
2.
2, because?
Because there are 2 parts like shaded.
Right, okay, so we need to remember, right, the relationship. What, so a lot of time we write this, but we don't know what does that mean exactly, right? So this is the denominator, this is the numerator, all right? Okay, all right, so here you go, equivalent fraction. What does that mean exactly, right? So now let's look at the first one. How do you say the first one?
3 out of 4.
3/4, right? Okay, so sometimes we say 3 out of 4, but the correct way to say the fraction is 3/4, right? Okay, so now a paper strip, have been divided into 4 equal parts, right? So now how many I should shade the first one to represent 3/4?
Shade 3 parts.
We should shade 3 parts, right? Okay. So 1, 2, 3, right? So that represent 3/4. Okay, so now why I said it is equal to 6/8. Okay, I'm gonna prove it to you, right? So now I'm going to fold this into 8 equal parts, right? Okay, 8 equal parts. So which means I need to cut each smaller piece into how many pieces now?
8 parts.
8 parts. So now each small parts, right? Now it was 4, right? So now if I want to cut into 8, I need to cut each small piece into how many pieces?
Into 2 pieces each.
Very good. Yes, 2, right? Okay, so now I'm gonna cut this into equal. Okay, so I do my best, so it should be equal, right? Okay, so now we have 1, 2. Okay, I'm gonna write it 1, 2, 3, 4, 5, 6, 7, 8, right?
And now because like the first one, it's like 3 parts, like 3 parts. So this one's like 1, 2, 3, 4, 5, 6. So
right, if you look at the number, right, equal. Okay, so now the first one stops here. So the second one, after we cut it into 8 pieces, right, the equal parts, the second part will become 6 pieces, right, to make it equal, right?
Yes.
Okay, so are you following me? Like, does that make sense to you now?
Yes.
Yeah, y 3/4 equals to 6/8, right? Okay, so definitely there are many more equivalent fractions. Okay, let's look at the next one, right? So we turn it into 6/8. I want to turn it into 9/12, right?
Well, this time, like you need to separate 1 part into 3 pieces.
Very good. Thank you. That's very nice. Yes, you got it right away, right? Okay, anybody else? I'm not hearing anybody else responding to the questions. Okay, please do participate, all right? Okay, so now, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, now equal parts. Let's draw this line down. So now,
9.
right now, total there are 12 pieces, right? But we want to take the equal parts, right? That would be 9 out of 12. All right. Okay. Anybody has question on this?
No.
No. All good.
Yes.
All right. Okay. So next, equivalent fraction. Okay, this is just another way of showing you the equivalent fraction, right? Let's say you have 3 people have the same size pizza, right? Okay, one cut it into 3 slices. Okay, so the first one, he ate 1, right? Okay,
Yes.
so this guy took 1/3. Okay, and the girl actually took 1/3 as well, but she cut the pizza into more slices, right? Okay, so the girl actually took 2 out of 6, 2/6, but they actually ate the same amount of pizza.
Because she cut it like in smaller slices.
Very good, yes, right? Okay, so now next, right? Okay, so now the third guy, right? He cut it into 9 smaller pieces, right? It looked like he ate more, but actually he had the same amount of pizza. Does that make sense now?
Yes.
All right. Okay, very good. Okay. So, all right, other than, of course, when the number gets too big, it's not possible for you to draw a pizza, right? Or to draw the paper strips. So, okay, let me show you one way you can do it, right? Okay, so what am I going to do, right? I'm going to do multiples, right? For fractions, I would like to remind you something very important. You must be good with your multiplication tables, right? Have you memorized your multiplication tables?
Yes.
Right. Okay. So boys and girls, I would like to remind you, you must be very good with the multiplication tables, right? You cannot count your fingers. It would take a lot of time, right? Okay. So make sure you do memorize your times tables. All right. So other than drawing pizzas and the paper strips, what are you going to do, right? You're going to multiply, do your multiplications, right? You can see here one trick. You can do it really quick, right? To do your equivalent fractions, right? So I would do 4 times 2, right? Okay, my denominator multiplied by 2, and you'll get 8, right? So when you multiply your denominator, you have to do the same to multiply your numerator as well, right? Don't forget about the other one, okay? So you have to do them both, right? 4 times 2 is?
8.
Right, 3 times 2?
6.
Right, okay, so now you got one equivalent fraction here, right? Okay, and the next one, you will multiply this with? 4 times 3, right?
12.
You see this here, 4 times 3, right? And you'll get?
12.
12, right? Okay, and then 3 times 3?
9.
Right, okay, let's go back to the previous screen, right? Okay, so you can see, right? See, are these equivalent fractions?
Yes.
Yeah, exactly the same way, right? Either you draw or you can, multiply your denominator and numerator with the same number, right? Okay, then you will get your equivalent fraction. Okay, any question by using this method?
No.
No? Okay, this is just one extra way, that I'm teaching you to do it faster, right? Okay, so let's try this one, equivalent fraction. So 3/5. Okay, give me an equivalent fraction.
3/5 equals to
9/15.
Very good. 9 out of 15. Okay, fantastic. Okay, could you tell me? Can we wait a little bit? Right, okay, let's check. Right, so what's the number you multiply with? I'm sorry, who did this question?
Me, Yushin.
So you times by what?
3.
Times by 3. Fantastic. Okay, so next, give me another equivalent fraction. One more person. One more equivalent fraction. For 3/5.
Everybody times
6/10.
times 2.
10. Okay, I heard 6/10. And what else? I heard 45.
Yeah, 45.
12/20.
Not 20.
27 out of 45.
Okay, 27 out of 45 because you multiply this with 9, right?
Yes.
9 times 5 is 45. 9 times 3 would be 27. Okay, fantastic. Okay, now, okay, let's check, right? Are they equivalent to 3/7? Okay. Are these equivalent to 3/7? Could you please tell me?
No, the first one, no.
The first one, no? Okay, what's wrong with the first one?
Because you can multiply. You can multiply the 7. So it makes 12 or.
Okay, the multiple of 7s would be what? Can you tell me the multiple of 7?
1, 7.
7 times 1 equals to?
7.
7 times 2?
14.
7 times 3?
It's 21.
Okay, so now here you go, right? Okay, if you do the multiple of 7s, right? Doesn't make sense, right? Cannot be 12. Okay, so this is not equivalent fraction. Okay, for this part, it is correct, right? This is correct, but this is wrong.
Yes.
So that make this equivalent fraction wrong, okay? Right, how about the second one? Can somebody?
9 out of 21, yes, it is.
Multiple of what? It is multiple of?
7. And also, 9 is also multiple of 3.
Right, okay. They both have to multiply with the same number though. Okay, so even, okay, so now actually you brought up a very good point, okay? So now, right, so 9 is a multiple of 3, 21 is a multiple of 7, right? But they both have to multiply, okay? So now 3 and 7, they both have to multiply with the same number to be correct, okay? Right?
Yes.
All right, so remember, right? Okay, 3 times 3 is 9. That's correct. 7 times 3 is 21. So this one is an equivalent fraction of this. That's correct. Okay, thank you for...
18 out of 49 is not equivalent because it doesn't it's a multiple of both numbers, but they don't multiple like with the same numbers.
That's right.
Because 3, it's 3 times 6 equals 18 and 7 times 7 equals 49.
All right. Okay. So now this is a multiple of 6. This is a multiple of 7, right?
Yes.
So that is not, right? Okay, fantastic. So this is the equivalent fraction. Okay, find the missing number here, please. Equivalent fractions. This is a little bit tricky though.
The first one I think is, oh, never mind.
Okay, this one is a little bit tricky. The number
Okay, I know that. The first one, the denominator is 9.
Okay, why it is a 9? Thank you.
Because 18, because 6 times 2 equals 12.
Yes.
And so it's like times 2. And 18 I divided by 2, so it becomes 9.
Fantastic. You have to think the other way around, right? Okay. All right. I think I probably have put this slide in the wrong place, actually, right? But we will talk about that later. Okay. But it's good. You are able to think the other way, right? Okay. All right. Now, anybody else? The second one?
The second one is 2 out of 3.
2 out of 3. How do you know it's 2 out of 3? Can you explain?
Yes.
Please.
So 12 out of 18. They all have to divide 6 and 10. 12 divide 6 equals 2. And 18 divide 6 equals 3.
Thank you very much. That is a very good explanation. Exactly.
And I know the third one. It's 4 out of 6.
4 out of 6, right? Okay.
Because
So what
6, it's like 6 times 3 equals 18. And so on top, so the numerator needs to be times 3 something. So I use 12 divided by 3 equals 4.
Very good, right? Okay, so I can also look at this one, right? I can do 3 times 2 is 6. 2 times 2 equals to 4 as well. Yeah?
Yes.
I can do that too. Okay, wow, very nice. All righty, actually, yeah, I put that earlier, right? Okay, so the next term, I want to introduce to you would be simplify the fraction to the lowest term, right? Okay, what does that mean exactly? So we can also say reduce the fraction to the simplest form, right? Okay, look at the highlighted part, the lowest term and simplest form means, I
know. So basically it's like I'm gonna give an example. It's 2 out of 4 equals 1 out of 2.
Right. You need to take out all the common factors, right? The 2 have the same factors. You have to take them out, right?
It's like the smallest factor. Is it like that?
Like, you have to, like, they don't have common factors anymore, right? Okay, so let's look at the example here, right? Reduce, or we say simplify, or we say reduce. Okay, how do we reduce the fraction, right? Go on diet? No.
So,
wait, go on. All right.
So I think that we can do like a factor tree or something, and like we just can divide up the things. Then
all right, so let's see, right? Okay. All right, so now let's look at the example on the screen now. Now I have 12, over 18, right? Okay, so now what I would do, I would see 12 and 18, they both can be divided by what? Okay, all right. I was just try because, I could see these are even numbers, right? So definitely I can start by, dividing by 2, right? So now 12 divided by 2 is?
6.
12, 6. Then 18 divided by 2 is
9.
9, right? So we have 6 over 9. Okay, so now, whoa, so now I got 6 over 9. Okay, so that's what I'm saying. You got to be good with the multiplication, your times tables. Now 6 and 9, can I divide them by 2 again?
No, because they are like 6 you can, but not the 9.
Why? Why cannot, divide by?
Because 9 is
An odd number.
Right, it's an odd number, right? Odd number cannot be divided by 2s, okay? So now I can see, these two are multiples of 3. So I'm going to go for 3, okay? So I have 6 divided by 3 and 9 divided by 3. So 6 divided by 3 is?
6 divided by 3 is 2 and 9 divided by 3 is 3.
3.
So they come to a prime number.
Right, yes. Okay, so now can I reduce this further?
No, because they're prime numbers.
It's already very small.
Right, you cannot really find any factors anymore, right? Okay, so this would be the simplest form or the lowest term, okay? So, when you're doing fraction, right, all the time, right, the best answer will be writing in the simplest form or the lowest term, all right? Okay, and make sure, right, can you do divided by 2 at the top and divided by 4 at the bottom? Can you do that?
No.
No, right? Make sure you divide both with the same number, right? Every time, okay? Right? You do 2 together one time, right? Then you do 3, okay? All right. Okay, next, your turn to do it. Boys and girls, your turn.
I know the next one is I know the next one.
Who is that, Lyndon? Can we have the girl? Okay.
Okay.
All right. Okay, thank you. Okay, the girl, I cannot see you, so could you please do it now? Who is the girl? Oop, the voice is gone. Okay, Lyndon, you do it. You go ahead then.
Okay, so the denominator is 18 and the numerator is 9.
Okay, the numerator, say that again, could you please? Like you divided by what to start with?
The denominator is 18 and the numerator is 9.
Okay, you divided these two by?
2.
2. All right, okay, next. Okay, can we do it further or this is it?
This is, no, we need to divide. So 9 gets to 3 because I'm going to divide it by 3. It's an odd number. And the 18, I'm going to divide it by 3. It's 6.
All right, okay.
It equals 1 out of 2.
1 out of 2, yeah. Very good. Thank you. Because, these you can be divided by 3, right?
Yes.
Okay, so you know what? So maybe like if for some people, you know what? I'm just going to skip this one, right? Okay, so if I go from here to here, what did I do?
Well, you just divided it by 9.
Right, you can just go by 9. If you know, if you know 18 is a multiple of 9, right? Okay, so you just right away divide by 9. Okay, anybody has a question on this part? So far, so good, right?
I think with another step, it's like just more precise. Like, I think with another step, it's just like more precise. Like you can make mistakes with that.
Okay. All right. Okay. So far, so good. Okay. So now we're gonna compare fractions. So we're done with the equivalent fractions. Okay. So once again, anybody has a question about equivalent fractions?
No.
Right. You can do a multiplication or you can do division, right? okay, to get your equivalent fractions. All right. Okay, so now we're going to compare two fractions. Okay, so the first is comparing fraction with the same denominator, right? Okay, right, the same denominator. How do you do the comparison? So the first one, I will shade one part, right? Okay, and the second one, 3/5, I will be shading 3 parts. All right.
So,
3 out of 5 is
3/5 is bigger than 1/5.
Right. So when you have the same denominator, you just have to compare the.
And like if we have the different denominator, we go for the biggest one. Then we look for it's like we look for their their
Okay,
multiples.
okay,
So then I multiply.
let's wait. Okay, don't jump to it now. Let's finish this. Let me make sure, right? Okay, everybody, gets this. Then we'll move on to the different denominator. All right. Okay. All right. So now, right? So now there are signs for you to use, right? So the first one means what? The one with the open mouth toward the left? Means what?
No, the one with the open mouth for the right.
Okay.
It's like,
we are not doing the answers now, right? This means greater or less or means equal.
Greater.
Greater, right? Okay. All right. And the middle, of course, we know it means equal, right? So now, okay, this one means what?
Less.
Less, right? Okay. So now when we have the same, okay, let's look at the denominator, the 5 are the both denominators are the same, right? So when you see the denominators are the same, you only have to look at the numerator, right? So definitely the one has more numerator, that one is bigger, right?
Yes.
Okay, that makes sense to everybody?
Yes.
Right. So I'm going to have the one is bigger would have the open mouth, right? Yeah?
Yes.
Okay. So 3/5 is bigger. Oops, where's my tool? Okay, wait a minute. Okay, my tool went away. Okay, so now let's go to the next one. Okay, so far so good. I only hear like 2. Oh gosh.
Yes.
All right, so far so good. Okay, let's do this practice. Now look at those 3 fractions, right? Greater than, equal, or less. Okay, first
I
one.
know.
4 out of 8 is bigger
4 out of 8
out of
is bigger than 2 out of 8. 9 out of 12 is smaller than 11 out of 12. 15 out of 15 is equal to 1.
1.
Okay, equals. Okay, so now, all right, very good. So now 1, right? So, there are 15 slices and you have all of them. Definitely you have 1. Very good. I was thinking maybe I could trick you, but I failed, right? Okay, so now let's look at the numerator, right? So now the same denominator. So 4 is bigger than 2, right? Okay, same denominator. So 11 is bigger than 9. Fantastic. So you got this. All right. Okay, so now look at this. Right? Who wants to do this question? Okay, arrange the fractions in order from the least to the greatest. So the least.
I know.
Okay, wait a minute, Linda. So least means what?
The least is the smallest and the greatest is the
yes. All righty. Okay.
So now I'm gonna start with 4 out of 10, and then 4 out of 4 out of 10, 4 out of 7, 4 out of 5.
Okay, 4 out of 10, 4 out of 7,
then
and
4
out of 5. Okay, could you please explain, right, why you arrange
the same numerator? So like the bigger the smaller, and the smaller the bigger. The smaller if the denominator is smaller, it's gonna be bigger, and if the denominator is bigger, it's gonna be smaller.
All right, the girl. Okay, what's your name? May I have your name, please? Like, what's the girl's name? Okay. All right. Okay, so.
Anna.
Okay, could you please explain that again? What you said about the pieces, the size of the piece.
So 5 is the biggest one because if the number is smaller, the pieces are getting very bigger.
Right. Okay, so now you can look at the picture here, right? So let's the picture here, you know, can help you kind of visualize and explain it better, right? So a lot of times we know, but also we need to learn how to explain it exactly, right? So, you know, at school when you're doing EQIO test, right, you have to write exactly, right, how you know it, right? So you need to be able to explain exactly, right, how it happens, right, and why you make that decision, why you know, take that step. All right, so now let's look at this. Right, so when you have smaller denominator, like, okay, you have, like, they have to be in the same size though, right? You cannot have one piece bigger, one piece smaller, right? If you are comparing 3 fractions like this, right, okay, they should be, in this case, right, they're in the same sizes, right? So now the same sizes, if you cut it into 5 pieces, right, compared to you cut it into 7 pieces, and compared to you cut it into 10 pieces, right, each smaller pieces, the sizes will be different, right? The less pieces you cut it, the bigger slice you're gonna have. Do you understand that?
Yes.
Right, the last, you know, you cut it into pieces, right? The bigger piece, each smaller part, that would be, right? Okay, so you cut it into 5 and you take 4, definitely you're gonna get more, right? Because you only cut it into 5 parts. But if you cut it into 10 parts, you know, then each piece shrank quite a bit, right? Okay, how much do you shrink compared to this? How much did it shrink? Like,
Well,
from 5, you cut into 10.
it shrank
5?
Yeah, not 5, like in halves actually, right? Right? It shrank in half, right? Compared to this, right? See here, right? From the first, okay, I'm gonna remove this. Oops, erase this so you can see better, right? Okay, if you're comparing this and this, right? So this is only half of this, right? Can you
Yes.
see that? 10 divided by 2 is 5, right?
Yes.
Okay, all righty. Okay, so now let's look at the second one, right? Okay. So let's compare the second one, B. So your turn to do it again.
So the first one is, so
Okay,
it's from big to small.
from least to the greatest.
Okay. 8 out of 2, 2 out of 8, 4 out of 8, and 7 out of 8.
Right, so this is much easier, right? Because you cut them into the same sizes, right? The more pieces you have, definitely the bigger it is, right? Okay, are we good? Are we good with the comparing fractions with the same denominator? Okay, fantastic. All righty. Now we are going to compare a fraction with a different denominator.
I know.
Okay, what do we do now?
So now we see the different denominators. Like now we see the bigger one. So it's 8 here. So now we're gonna find the 4 times what equals 8. So 8 divided by 4 equals 2, and 4 times 2 equals 8, and the numerator does the same thing. 3 times 2 equals 3 times 2 equals 6. And now 6 is bigger than 5.
Okay, so now we have, so after turning things to the 8th, right? So we have 6 over 8, right?
Yes.
So 6, so now we turn them into the same denominator. We have,
and now we can compare.
We can compare the numerator. Fantastic. Okay, for some people, I'm going to draw. There's another way to do it, right? Okay, for smaller denominators, right? So now we can cut the 4. Okay, so now 3, 4 is like this, right?
Yes.
Okay, so now if I cut into 8, right? So I will have 1, 2, 3, 4, 5, 6 here. But the second one, right? There is 5, right? So definitely this one is bigger, right?
Yes.
Okay. There is a different way for you to understand. Okay. So now let's take a look at this. Compare fractions with the different denominators. Okay, the first one, which one is bigger?
I know.
Okay.
It's 5 out of 6 is bigger.
Okay, why?
Because now I'm gonna do 6 divided by 3 equals 2. Times 2 equals 6, and but 2 times 4 equals 4. Now we have the same denominator we compare, and 4 and 5 is bigger, so
right. Okay, I think you meant to say 2 times 2, right? Okay, so I think, okay, it's 2 times 2, so it's 4, right? So we turn 2/3 into 4/6, right?
yes.
Okay, all righty. Okay, next.
For B, 4 out of 5 is bigger than 7 out of 10 because 7 out of 10 has more space.
Okay, Galena, could you explain that again? So now you turn 4/5 into what?
4/5?
Right, you turn 4/5 into?
I didn't turn it.
Okay, I didn't hear you properly. Could you?
So 4.
Okay, wait a minute, I have.
So every other
Galena,
can multiply 2, so it equals 8 out of 10.
8 out of 10. Okay, so now I saw who is like the girl you just put your hand up. Could you please tell me your name?
Yishin.
Yixing. Okay, Yixing. So now Galena said it is 8 out of 10, right? Do you agree?
Yeah.
Okay, so
Yes.
why you agreed?
It's because 5 times 2 gives you 10, and 4 times 2 gives you 8.
That's correct, right? So now we could compare, right? So now this is bigger, right? Because 8 is more than 7, right? Okay, fantastic. We have more people to participate. Okay, so now, wow, this one. All right, so now we have 3/9 and 5/5. Okay, so do you remember at the beginning I talked about the common multiple? What
Yeah.
does that mean exactly? Common multiple.
So
now, like, let's go back and take a look, right? So now we can turn, we know 3 and 6, right? 6 is the multiple of 3, and 10 and 5, 10 is the multiple of 5. But now, 9 and 6.
I know how to do it.
Okay, wait a minute, okay?
I
So
think that we can make a factor tree.
you can make a factor tree. Okay, so I would explain my method, then you can share yours, okay?
Okay.
All right. Okay, so now, right, so for 9 and 6, okay, 9 is not a multiple of 6. 6 is not a multiple of 9. So how do we do that? So, that's what I'm going to.
So, okay.
Okay, so now, right, so what I'm going to do, I'm going to start doing my multiplications, right? Okay, so I'll do 9 times 1 equals 9. 9 times 2 is 18. And I'm going to do 9 times 3 equals 27. Okay, I kind of know, so I will stop here, right? And then I'm going to try 6, right? 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. Woohoo! Yeah, I found it, right? I found the smallest common multiple, all right? Okay, the first multiple, you find it, you're going to use that, right? Okay? So I'm going to use 18 as my denominator now. Okay? So 18 is the lowest common multiple, okay? All right, so now I turn my denominator into 18. What happens to my numerator?
It multiplies by it multiplies also like the same thing. So like 9 times 2, like 3 times 2.
So 3 times 2 would be?
3 times 2 will be 6.
Right. So and 5, I will multiply it with?
2.
2?
Like 3 times 2 equals 6.
But, you know, this is from 6 to 18.
6 times 3 equals 18.
And I would do 5 times 1.
And 5 times 3 equals 15.
Yes. So which one is bigger?
So 5 out of 6 is bigger than 3 out of 9.
So this is bigger, right? Okay. All right. So Lyndon, okay, that's, you know, thank you for making that mistake. I was expecting that, right? Okay. So you have to look at from 6 to 18, right? How many, what's the number you're multiplying with? 3, right? Okay, here you go, 3, right? All right. Yeah. So that's one method you can use, right, to find the lowest common multiple, right? Okay. So there's another way. You know, if the numbers are too big, I really don't recommend you to do it, right? Can I just do 9 times 6? Can I do that? Can I? Okay, all right. Let's go back and let me fix myself. Can I turn my denominator into 36?
No.
Aren't
they equivalent fractions?
Yes.
Yes, you can.
Yes, if I write it as, if I want to do 36, I can do that.
Yes.
And what would be the numerator on the top?
Like 5 times 6.
No.
For
this one, right? If I want to turn 39 to what? 36.
9 times 4 equals 36. So 3 times 4 equals 12.
Right. So yeah, I can use 36 because 36 is a multiple of 6 as well, right? Okay, yes. There's nothing wrong. Okay, so now, okay, let's see. Can I do 9 times 6? If I can multiply the denominators with each other, can I do that? Can I do that? I'm going to erase all this, right?
Yes.
Okay, let me erase all this so to make the screen clear. Okay, so I can do 9 times 6. Okay.
Yes.
And I can do 3 times 6 here, right? Okay. So that, and what do I do on for this one?
Times 6. No, this one is if like you want to do 36.
Okay, if I do 9 times 6 here, right? 9 times the other one, and this would, I will multiply this with what? Which one?
6 times 6.
No, 9. Because 9 times 6 is, what is 9 times 6?
9 times 6 is 54.
Right, so you need to make this 54 as well, right? So you have to type, like you kind of switch, right? Okay, if this, you have this multiply with the other one, 6, then 6 definitely you multiply with the other one, which is 9.
And 5 times 9 is 45.
So you have 45 over 54, and you will have 18 over 54, right? Yeah? Then still, this is bigger.
Yes.
Same answer, right?
Yes.
Okay, so this is a second method you can use, right? Okay, the first one is to keep multiplying by 1, 2, or 3, right? Until you find the common multiples. The second method is multiply with each other. Okay, so now there's a third method coming up, okay? Actually, there are 4 methods. Let's see if we can get to 4 methods, all right? Okay, so now the third method would be, okay, so we're going to find the lowest common multiple again, right? So the lowest common multiple, there's another way of doing it, okay? So we're going to find all the factors of 9, right? The factors of 9, what are the factors of 9?
1 times 9, 3 times 3.
Okay, so now, right, 9 is 3 times 3, right? Okay,
Yes.
right? So we break it down, right? So 9 is 3 times 3, and 6 is what?
6 is 1 times 6, 2 times 3.
Very good, right? So now, okay, so now we see, right, the 3, like they both have 3 one time. Okay, here you go, right? So we're going to only write this one time, okay? So we're going to do 3 times 2, right? Okay, 3 times 2 here. Okay, they both have 3 and 2. But, 3, they both have 3, right? So we're going to just write these 3 once. Are you getting this one?
Yes.
So you have 3 times 3 is 3 times
3 times 3 is 9.
9.
three
And 9
times-
times 2 equals 18.
So here you go. We found our lowest common multiple. Is that interesting?
Yes.
Okay, can somebody repeat, right? Okay.
So we can find the multiples of 9 and 6. So 9 is 3 times 3 and 6 is 2 times 3. Then we see that 9 and 6 both have 3. So 3 times 3 times 2 equals 18.
Right, if they both have the same factor, right, you only have to multiply it once, right? Okay, so these are factors. If you see they both have the same factor, right, just write it once, okay? All righty. Very good. All righty. So let's arrange. Okay, do you want to learn the 4th method?
Yes.
How to do the, okay, so let's try, okay? So now we're going to write it like this. So 9 and 6, right? Have you kind of seen this kind of division before?
No.
Okay, this is the 4th method I'm going to teach you, right? Okay, 9 and 6, the common factor, so they both can be divided by what? They both can be divided by?
They both can be divided by 3.
Okay, so I'm going to write a 3 here, okay? All right, so
Yes.
9 divided by 3 is?
3.
Okay, 6 divided by 3 is?
Oh, I know this method.
Yeah, okay, 6 divided by 3 is?
2.
2. Okay, can 2 and 3 be divided by any number again?
No.
No, so we are done. So what are you going to do? Hooray. So we're going to do 3 times 3 times 2.
Yes.
Yeah, you got 18, right? Okay, fantastic. So you learn all 4 methods to find your lowest common multiple. All right? Okay, sounds good?
Yes.
All right. Okay, so now let's do this. So, okay, we have 5 more minutes. Then, you know what? It's just about right amount for today. Okay, arrange the fractions from the least to the greatest. Okay, so first one.
The first one.
Okay, so who wants to do it? The least to the greatest?
The least to the greatest.
Okay, so we have 3/5, half, and 9/10.
Oh, I think I know it now.
So what's the lowest common multiple? Tell me.
It's 5.
No, the lowest common multiple. Okay, there are 5, there are 2, 3, 10, right? What's the lowest common multiple between 5, 2, and 10? Oh, shoot. Okay, the lowest common multiple. Okay, remember this term. Where's my tool? Lowest common multiple, LCM. Lowest common multiple, right? Okay, 5, 2, and 10. What is the lowest common multiple?
3. 30.
Okay, let's go back and okay, we need to understand. Okay, remember. Okay, I know this is the first time. It's okay, right? Let me go back and show you what does the lowest common multiple mean, right? So what is the lowest common multiple between 9 and 6? Okay, let me scroll back a little bit. Okay, lowest common multiple, right? So when you do the multiplication, eventually they get to the same number, right? Okay, can you recall? You remember the term lowest common multiple? Common means they share the same multiple. And the lowest, right? So 5, 2, and 10, what's the lowest common multiple?
8.
Okay, can you multiple of 5, is there 8?
Oh, it's 8. It's 10. It's 10.
Thank you. You got it. I think you just, I know you just somehow got confused for a little while, but you came back right away. Great. Okay, should be 10, right? So now we're going to turn all the denominators into 10. So 3/5, if we turn into, change the denominator into 10, then 3/5 will become 3/5 equals to
10. 3/5 equals to 10.
What's the numerator?
I think it is
So you multiply by what to get to 10?
2.
2, right?
Like 3 multiplied by 2, it's 6.
Yes. Okay, and 1/2 equals to?
1/2 equals to 5 out of 10.
That's right. So now we can do the comparison, right? So now this is 6/10. So now this is 5/10, right? And we have 9/10. Okay, so which one is the smallest?
5/10.
Yes, this is the smallest.
And 6 out of 10, that's 9 out of 10.
Fantastic. All right. Okay, so next one, let's look at the next one. What's the lowest common multiple for 2, 4, and 3? Let's find the lowest common multiple first. 2, 4, and 3, okay?
Yes.
Okay, let's find the lowest common multiple. Okay, can you tell me, Glenna, can you tell me one of the strategies to find the lowest common multiple? What can you do?
This one?
Right, for 2, 4, and 3, find the lowest common multiple.
Lowest common multiple.
Would be, yeah, one of the strategies.
One of the strategies.
Okay, let's go back. Okay, I'm going to go back. How did I do the lowest common multiple? Maybe, we can try this, right? Okay, let's go back and take a look. We have 2, 4, and 3, right? Okay, 2 times. Okay, I'm not going to do 2 times 1 first. I'm going to do maybe 2 times. I'm going to start with 4, maybe. 2 times 4.
2 times 4 equals 8.
Huh?
2 times 4 equals 8.
Okay, 2 times 5.
Yes.
2 times 5 equals 10.
Okay, okay, 2 times 5 is 10. 2 times 6?
2 times 6 is 12.
All right, 12. Okay, do you think 12 is a multiple of 4 and 3?
Yes.
Yeah.
Yes.
Okay, we're going to try the other two. Okay, 4 times. So I'm going to do the 4 times what?
4
times
times
2.
Okay, so I'm going to do 4 times 2 first, right? Okay, 8. Okay, hey, I saw 8. Should I use 8?
Yes.
Why?
Yes.
But there's a 3 though. Do you see 3 here?
Yes.
Yeah.
But 8 is not a multiple of 3.
You
So
should
we
use
can.
12.
Yes, we have to use 12. So now we go next, right? 4 times 3 is 12, right? Okay, let's try 3. So we're going to start with 3 times 3, okay? 3 times 3 is 9.
9.
Right. Okay, and 3 times 4 is?
12.
12.
Right. So what is the lowest common multiple for 2, 4, and 3?
12.
Wow. Yes. Okay, so we're going to go back to do this question, right? Okay, so maybe next time we have to practice a little bit more about the lowest common multiple, okay? All right. Okay, so now we're going to turn all this into 12, all right? Okay, so now let me erase this. I don't have a lot of space to write here. Okay, and I don't want to switch to the whiteboard. That would take time. Okay, so now 1 over 2 equals to what over 12?
1, 2 equals to
So 2 times what equals 12?
6.
Yes. Oh, so we're going to be quick.
1 times
And the next one is
times 6 equals 12.
Yes. Okay, so now 4 times what equals 12?
3.
So the numerator would be?
3.
Huh?
Yeah. 4 times 3 equals 12.
3 times.
So well, the numerator will be
3 times what?
The
3 times 4.
numerator will be
3 times
9.
3.
Yes, Glenna, thank you. Okay, somebody's losing concentration. It's lunchtime. Okay, so now, all right, so now 2/3 would become what over 12? So 3 times what equals 12?
4 and 2 times 3 equals
2 times 3 again?
no,
2 times what?
2 times
4.
4, 8, right?
Equals 8.
8.
Right.
8 out of 12.
Okay, that's right. Okay, so let me erase this again. Right, so we have what? So we have 1/2 is 6 over 12. Oops. 6 over 12. And we have 3/4 is 9 over 12. And we have 2/3 8 over 12, right? Okay. So now you can compare. All right. Okay, so when you're writing your answer, remember you have to write this, okay? You have to write like this. You cannot write this, okay? So you have to say the smallest one is this, right? 1/2. So you have to write 1/2. And the second one is 2/3, okay?
Mm-hmm.
And the biggest one is what? 3/4. All right. Okay, so now the answer would be written as such. Okay. All right. Okay, it's exactly 12:25. Okay, so how do you feel about the class today?
Good.
Good. Did you learn anything new?
Yeah.
Yeah. Did I clarify some of your concepts? Yeah, but in the future, okay, we keep working on it, right? But you're pretty good. But I would like to have more students to participate, right? Actually, I have one more to do, but I think time is up. All right. Thank you, Glenna. I like your heart. Thank you so much. Good girl. And who is that? Could you please tell me your name again? The one who raised your hand earlier? You know, I'm sorry, I'm not very good with names, okay? All right, and Lyndon, thank you for your wonderful participation. I really appreciate that, right? You guys make the class more interesting, okay? So I hope, and I will see you again, all right?
Okay.
Okay, and you have a wonderful Easter.